I'd like to start with the basics. I make a very simple block that consists of only one square. The size of the square can then be changed according to a given table. The object in the block is currently freely movable and editable. The problem with this is that it would take a lot of parameters to get the sides to hold the rectangle. Use auto-constrain to force the object to keep right angles and parallels. These icons show what constraints have been created. The parallels and right angles in the object are preserved under all circumstances. If you hover the mouse over the icon, it will show you the element of the object for which you have created a constraint. For simple objects, you can turn on Infer constraints at the drawing stage. But in the dynamic block, you should stick to the option to create it automatically. The block is currently static. We can only resize it with its geometry properties. Now we need the constraint parameters. Dimensional constraints will be used later. First, select horizontal parameter and mark the start and end points. This will be the width. Then select the vertical parameter and select the start and end points. This will be the height. Arrows are located at the endpoints, which you can use to resize the rectangle. You can also specify the exact size in the Properties panel. Of course, you can specify mathematical operations. For example, the height should be half the width. This is implemented immediately in the block editor. And of course, only one of the parameters can be specified, while the other is a fixed, calculated value. Now let's make a table. Place it on the drawing. The grip number should be 1. The first icon to add the parameters to the table. You can fill in the table manually. But you can also paste a pre-made Excel spreadsheet. Make sure that the calculated values cannot be overwritten. We can now set the desired rectangle size from a table. But you can also use the Property panel. You can add more columns to the table. This is now a string. You can change the order of the columns. Note that the identical elements in the first column form a group. First, I make an elevation. The post should be 300 wide and 1200 high. The fence post width should be 40 and the height 600. Copy the post to 1200 millimeters. Draw 1100 high wall between the two posts. Draw half-wide walls on the other side of the posts. Draw a fence between the fence posts. This should be 50 to 50 smaller than the fence posts above and below. Also copy this half the width to the other side of the posts. We will now create a top view of this. Make a cut view after the top view. Explode all elements of the drawing until the drawing consists of simple lines, so that no unnecessary constraint is created. Execute the auto-constrain command. Since the block will be continuously tested, we can ignore the predictability warning for now. Now there are not only icons, but also small blue dots. These are the constraint for joining two different objects. We will not work with these now, so we can hide them. Create a horizontal parameter right away and test it. This should be the width of the post. You can see that the post width is already set in two views, but the rest of the drawing completely falls apart. Now we will need the dimensional constraints. With these we can fix the horizontal distances whose values we do not want to change. Add value to the second post. This will also be a fixed value. It should take the value of the first post. Add the distance between the two posts and test the block. You can see that the widths already specified work, but some elements do not yet follow them as desired. Already the posts are keeping the specified spacing. Fix the width of the fence posts and specify their distance from the edge of the post. This value will be the difference between the width of the post and the width of the fence post. Since the post width of the fence is fixed, we can enter the number. For the other it is enough to refer to this distance. The fence posts now move properly with the posts. Now let's define the heights. To do this we apply the vertical parameter. Define a total height. The height of the fence post will be the difference between the total height and the height of the post. The height of the posts can be adjusted even in cut view, but the walls are not yet in sync. Make the height of the wall dependent on the height of the post. Then pull the fence with a vertical constraint. The side view is done, followed by the top view along the x-axis. The y-axis is still completely stationary. In this view, the post width vertical must also be specified. I choose square for now. The posts pick up the value, but the walls and fences do not follow the drawing. We will need the wall thickness in any case. And to make the wall follow the post, you must first specify it. Specify a mathematical operation for the vertical parameter, so that the wall is always on the axis of the post. Do the same with the fence post. Fix the dimensions of the fence post. If you try to enter a value that is already fixed, you will be warned that it is not necessary. So here you only need to fix a vertical value. Do the same with the fence. Now in this example, the width of the fence should also have a fixed value. The top view is also finished. You can see that the values are completely in sync. In the cut view, I will place only one parameter, the height of the foundation. All other dimensions will be solved by dimensional constraints. Fix the fence post width here too. Then do this with the distance of the fence and the fence itself. Also fix the vertical distance. The fence post spacing has already been touched once, it was D5. Fix also below the fence vertical distance. Here the post width is also simple, it was the first value we entered. The distance to the wall has already been given once. This was the D8. Fix also the horizontal value of the foundation. Then the vertical dimension. Last but not least, the wall thickness. This is the WT. For the sake of clarity in this example, I have tried to keep it simple. Therefore, many dimensions have been fixed, which of course can also be user-changeable parameters. You can access the table with this icon or with the table command. I select the relevant parameters. You can also put the calculated parameters in the table, but they cannot be overwritten, so they only take up space. Add a string parameter to the table, but you can of course add more. Fill in the table by typing. Or copy your data from an external table. The block table is ready. Of course you can change it in the block editor at any time. The block is ready. Prepare dimensioning. The full list of block tables is displayed in the pop-up menu. The whole drawing takes the values given in the table. You can open the table and select an item from there. The dimensions are the same as the values in the table. The values overwritten in properties will appear in the drawing, but will not change in the table. You can change them in the block editor. If you choose the right one, you can use hatches. I hope I have captured your imagination with this simple example. Thanks for watching.